Hello everyone. What I want to do in this video is talk about the reason behind why the geometry magic trick works, which I have discussed in my article. The link to that article is in the description below. You can check that out. But if you have not checked it out, don't worry. I'll show you what the magic trick is all about. So, and I'll be using GeoGebra for this. It's a very useful and easy to use tool. So the magic trick requires just one. There's only one requirement for that magic trick. What you need is you need a triangle out of which has one angle which measures 30 degrees. So what I have here is a triangle, and this my angle A here is 30 degrees, and I can even show that it is actually 30 degrees by measuring it out. Let's measure it out. So this you can see that it's actually 30 degrees. The next step for that magic trick to work is what you are expected to do is construct the circumcircle for this triangle. So a circumcircle is nothing but a circle which passes through the three vertices of the triangle. So if you were doing this on a piece of paper, what you would do is draw the perpendicular bisectors for all the sides, and the point at which the perpendicular bisectors meet, that will be the center of the circle, and you can use one of the vertex to find the radius and construct the circle. But since I'm using GeoGebra, what I can do is I can easily draw the circle passing through the 3 points. So I have this option which says circle through 3 points. I can use this, and I can put in these A, B, and C points to give me the circumcircle. So this is the second step. This is the circumcircle, basically the circle which passes through the three vertices of the triangle. And what I claim in that geometry magic is the radius of this circumcircle. It is equal to the side opposite to the 30-degree angle. So if you see this side BC, it is equal to the radius of this circle. That's the magic trick. And yeah, of course, it's not a so-called a magic trick. That there's a really good proof behind it. That's what this video is all about. So yeah, to show that, let me first construct the center of this circle. So I'll need the center. This is the center of the circle, and just to demonstrate that the magic trick actually works, I'll draw one of the radiuses, one of the radii. Let's construct a point on the circumference. So let's say this is a point, and if I draw the line segment joining the center to the point, you can see that this line segment is equal in length to this line segment BC, and I can even show you to by measuring the line segment. So I can use the distance property. You can see that this in this example, it's this measure is 3.8, and if you were to measure this would be voila 3.8. It's the same thing. This is the magic that I was talking about in the article, and I can even, you can see that this is actually the radius, and this is the distance. So yeah, this is where the proof of the magic trick, because this is the reason why the magic works. The very important property regarding this triangle is that it is in this 30-degree angle, this is the angle subtended by these 2 points B, C. So when you have an angle subtended by 2 points, or rather arc, a very important geometry property is that the central angle created by these 2 points, that is this angle. I can even construct the central angle. So this this angle is equal to double of the subtended angle. So if this is 30 degrees, this would be 60 degrees. This is a property of the circles and triangles. And I can even show it to you by measuring the angle. Let me again go, and so you can see that that is 60 degrees. And this is the crux behind the geometry magic. If you have this 30 degree, this will be 60 degrees for sure. But this is half of the proof. What I can now claim is, since BC, or rather CD and BD, these are radii of the circle, then this triangle is an isosceles triangle, right? Because this side is equal to this side. Both of them are radii. So by the property of the isosceles triangles, I can claim that this angle is should be equal to this angle. But since one of these angles is 60 degrees, the other two have to sum to 120 degrees. And since both of them are equal, they must be 60 degrees each, right? Because half of 120 is 60. So 60 should be this and this should be 60 as well. And I can even show it to you by measuring the angles. I can show that this is 60 degrees and this, oops, this is also 60 degrees. So you can see that these two angles are also 60 degrees. And what do we have here? What do we have here is actually an equilateral triangle. All the three angles are 60 degrees. And since then this was the radii of the circle, this was the radius, and this side was the side that I was talking about, the angle, the side opposite to the 30 degrees angle. Since this is an equilateral triangle, you can clearly see that the radius should be equal to the side BC. So you can even measure it. I can measure all these sides to show you that these are actually the same. So yeah, it's just a simple proof of showing that the geometry magic works. It basically says that the radius is equal to the side opposite the 30 degrees angle. So I know a very simple proof, but what you can do is if you are an educator, you can use such small magic tricks to help your students get engaged with geometry. Thank you.